Hi, welcome back to the channel. So from this video we will see about the Zener diode. This is a very important diode. We will see what is the definition, what is the characteristics of this. Okay. So if you recall the VA characteristics of a normal PN junction diode, what exactly happened is, so this is a VA characteristics, right? So in this forward voltage, forward current, reverse voltage, current, reverse current, like this it is there, right? First quadrant and it is fourth quadrant is very important. We are seeing in case of the fourth quadrant, what is happening is it is breakdown voltage. Means if you start increasing the reverse voltage, what is happening? So initially it becomes constant. We have called in the previous case it as reverse saturation current as I naught, but after some voltage, that is the diode will breaks, PN junction breaks, that is called as the reverse breakdown voltage. So the diode will breaks, right, in the reverse biasing conditions. But now this is a type of diode, it is going to work in the reverse biased voltage up to some extent. So that is the characteristics of Zener diode. So now look at the symbol of the Zener diode. We will write the normal PN junction like this, but for Zener diode we should write like this, right? Same plus or minus, right? So here that is what we have taken. So here, what is the meaning of this? Why we should use this is, if I take this Zener diode, what is the help of this is, which it is called as also as shunt regulator or the voltage stabilizer. This Zener diode is going to be used in the voltage stabilizer where it can withstand the voltage. What is the purpose of this? It is going to take the unregulated power supply or the input voltage, and it is going to give you what type of output voltage? Regulated output voltage. Means it is, in the normal terminologies, it is fluctuations here and it is constant here, right? So for that, what is the element we will use? Zener diode, right? For that, we will use a series element which is in through which the current I flows, then Zener diode through which the current IZ and the voltage VZ and the current IL through the load resistance, and we are taking this parallel combination. That's why it is called as shunt regulator, right? So here, this is a point we are very much interested. At this point, in previous case if breakdown occurs, but at this point now your diode is not going to get break, but it is going to withstand as long as the current is between the IZ minimum and IZ maximum. This is the current IZ. It is having some minimum current and maximum current, and between this region, it is going to withstand, right? So, and it is current, that is the voltage Vz is going to be constant. The voltage Vz is going to be constant between Iz min and Iz max. Voltage Vz is constant between the Iz minimum and Iz maximum, right? So that is what the advantage of Zener diode. So now after this, it is having two types of now regulations. These regulations, we'll call it as regulations, line regulations and load regulations. What is the meaning of line regulation? We will see that now. Line regulation is nothing but you should vary the input. We should vary the input and we should see what is going to be the changes. Before that, we should write here one formula. What is the formula we should write for the current now? So look at what is the current here. We can write the current I is equals to, what is the input voltage V in minus what is the voltage of this Zener diode, that is Vz, divided by what? R, yes, that is this, right? I is equals to V in minus Vz divided by R. So what is this? It is nothing but it is constant. Or you can write here through this, the current IL is equals to Vz divided by RL. Vz also can be written as V0 divided by RL, which is constant, right? This is a conclusions we can take, and also we can write one more equation. I is equals to Iz plus IL from the KCL, Kirchhoff current law. At this node, the current which is entering is I, current which is leaving is Iz as well as IL. So this is the concept we should know before proceeding into the next section, right? So constant, at here we should get the constant current, that is IL, right? And also we can write it as Iz also, both are same, Iz and IL both are same, but this should be constant. So now we will see with the help of this circuit diagram how exactly the line regulation will be. With the help of the equations also we will see. For that we will take the same input. So we will take the heading, we will take this heading as line regulation. Line regulation or Zener diode, which acts as a varying input voltage. We can also write it as varying input voltage. Means whatever the input which we are taking, so we will write like this. Vary means we will write like this. Right? So this is varying now. For this combination, we should see how exactly this circuit diagram works. Right? For this, first we should write here the current IL. What is current IL? It is nothing but V by R. What is V? VZ by R. What is R? RL here. R we can write it as V naught by RL. What is this current? The current IL is constant because it's the output side. Regulated. Regulated means what it is? Constant. Right? So we should get the constant voltage. And also we know one more equation. What is that equation? I is equals to the total current I is equals to Zener current plus load current. Right? So this is the equation. Now suppose here we are interested in this. So I will take the case number 1. What is the case number 1? We will divide this into case 1 and case 2. What is the case number 1? Case number 1 is saying when input Vin increases. You will see this case. If V increases, what is going to happen? We know that V is directly proportional to I. If V increases, the current I increases. Right? So, if current I increases, look at the LHS here. Right? Current I increases, look at the LHS. What is going to be this LHS will start increasing. Current I increases. If this increases, what about the IL? IL is what? It is constant. Right? So I will write here I is increasing and we know that IL is constant. Then we have left out with this option. What is that? IZ. What is that IZ? How we can write now? This is constant, this is increasing, then this should be what? Increasing, so that it is compensating. I increases, IZ also increases because IL is going to be constant as long as it is VZ is between IZ minimum and IZ maximum. That is the first case. What is the case number 2? Vin decreases. Vin decreases. If Vin decreases, what about this? Because V is proportional to I also decreases. This I decreases. So we will write that I is equals to IZ plus IL. We know that this is constant, this is decreasing, then what should be decreasing? IZ should decrease. This is constant, it is not varying. It is decreasing means this should decrease, right? So that is what the conclusion we can make, that if Vin increases, I increases, IZ increases. If Vn decreases, I decreases and IZ decreases, right? Because your IL is constant. So this type of concept is called as what? It is line regulation. So line regulation can be written as delta V output divided by delta V in into 100%. It is called as line regulation. Right? So this is the concept of Zener diode when we take varying the input voltage. Right? So very simple concept, so that if you understand this equation, then you will understand it. Right? So now the second one, in this case also it is acting as a voltage stabilizer because output is constant. Second one, we will take the next regulation. What is the next regulation we will take? Load regulation. what it is? Load regulation, right? And here in this case the input is constant. Whatever the input we are taking, that is constant. What is varying? Load is varying. This is variable, right? So for this, we should see the remaining parameter, how exactly the circuit diagram works, and what is line regulation, what is load regulation also we should see. So can you think what is going to happen now with respect to uh, load regulation? So this is also the case number 1 and case number 2 you will get. So can you think that Zener diode which acts as a varying load which is constant. So here how best you can take is this equation you can take this also. Here it is not output is constant, so I will remove this. So we know the equation I is equals to what? V in minus Vz divided by Rs. Since V in is constant, so this is constant, so what you should write now? This is constant. What is constant? I is constant, right? So if I is constant, we should see the probability, right? What is the probability? We should take the case number 1. What is case number 1? Case number 1, we should see RL, because RL is varying. When RL increases, this is the case number 1. When RL increases, what about IL? IL is decreasing. Why? Because we know that V is equals to I into R. So R is equals to V by I. Right? I and R, look at this, inversely proportional to each other. So if R increases, I decreases. IL decreases. So I will take the help of the known equation. I is equals to Iz plus IL. This is the equation we know. So we know that IL decreases. Where is IL? This is decreasing now. And what about this I? I is constant. This is constant. So this should be constant. This is decreasing. What should be this? This should increase. Increasing, decreasing, so that it is going to be constant. So similarly, can we do with case number 2? What is case number 2? So you should take the RL which is decreases. RL decreases. What is going to happen? IL, what about IL? IL should increase. Right? Same equation, I is equals to Iz plus IL take. What is the IL now? IL is increasing. What about the LHS? LHS is constant, right? So what about this? This should decrease. Iz should decrease. So here Iz should decrease. Here Iz should increase. Right? So that your I is going to be constant. Your I is going to be constant, right? So now here also percentage of load regulation. The load regulation is V no load, full load. V no load minus full load divided by V full load into 100%. What is this? Load regulation. What it is? Load regulation, right? So this is the formula. So these are the basics of Zener diodes with respect to shunt regulator and voltage stabilizer. We are having two main concepts. One is the line regulation, varying the input voltage. Second one is load regulation by varying the load, right? So this equation is very important in both the cases. And which is the constant? In the first case, output side is constant. In the second case, input side is constant. That you should take it, right? Thank you. We'll see you in the next video. If you have any doubts, you can put it in the comment section.